students, Chapter 7, System of Particles and Rotational Motion. We have completed one section, that is System of Particles. For System of Particles, what is center of mass, what is velocity of center of mass, acceleration, forces, etc. etc. Yes, we have completed all theories and yes, sums also. Now we will see the next portion of this chapter, which is rotational motion. If you have observed motion of merry-go-round, motion of fan, motion of earth about its own axis, okay, so yes, these all motions that you have observed, they are called rotational motion. So what is rotational motion? Okay, we will study in detail in this chapter. And yes, the properties, the characteristics, okay, dynamics and kinematics of rotational motion, that we will see in this chapter. Okay, yes, we will start this portion first with one definition, that is rigid body. Yes, we know what is rigid body, but we will repeat. Okay. Rigid body. What is rigid body? If distance between particles, if distance between particles remains invariant, if distance between particles remains invariant, means distance between particles does not change, okay, such body is called rigid body. Such body is called rigid body. Okay, yes, rigid body and solid body, they are not same, because solid body can be deformed. Deformed means if we apply force. What is meaning of deformed? Deformed means if we apply external force, there is change in its shape, its size or its length, means it is said to be deformed. So yes, solid body can be deformed, while rigid body cannot be deformed. Clear about this? Rigid bodies cannot be deformed. And yes, rigid body is ideal concept. Rigid body, it is ideal concept. Clear about this? So yes, this point you have to remember. What is the difference between solid body and rigid body? But for some practical purpose, we can consider solid body as rigid body. Again, I am repeating my statement, okay. For some practical purpose, we can consider solid body as rigid body. For example, this board. Yes, this board. You are observing this board from Mars. Okay. So yes, distance between any two particles does not change. Yes or no? So yes, I can consider in that manner this board, means the solid body, as rigid body. Okay, because there are no changes in dimensions, in part distances between this board. Clear? So yes, for practical purpose, I can consider some solid body as rigid body. So yes, first point that you have to remember about this topic is what is rigid body and what is difference between solid body and rigid body. Now next one is what is rotational motion? What is rotational motion and axis of rotation? Okay, two definitions. First, what is rotational motion, and second, axis of rotation. So yes, we will see this with help of one example. Okay, for example, I have one body like this. If I have one rigid body like this, okay, if this particle of rigid body is performing circular motion like this, if this particle of rigid body is also performing circular motion like this. If this particle of rigid body is performing circular motion like this particle performing circular motion like this one performing circular motion like this. Okay, so if all particles of rigid body are performing circular motion and their centers lies or their centers are on a definite straight imaginary axis, then such motion is called rotational motion, and this axis is called rotational axis or axis of rotation. Clear? Again, if one object is in motion such that all particles are performing circular motion, and their centers lie or coincides on a definite straight axis, then such motion is called rotational motion. Okay, so yes, how to write definition? Okay, if all particles of rigid body are performing circular motion and centers of these circles are fixed on definite straight axis. If all particles of rigid body are performing circular motion and center of these circles are fixed on definite straight axis, such motion is called rotational motion. Clear about this? So yes, such motion, it is called rotational motion, and axis is called rotational axis or axis of rotation. Clear? So yes, this imaginary line, it is called axis of rotation. Clear about this? So yes, it is rotational motion. See now how to prove this one. Take one page. Okay, page of your notebook. Okay, now from that midpoint, by holding that midpoint with the help of your finger, rotate that page. Each and every particle will perform circular motion. Or if you have fan, okay, yes, you will have fan. Okay, if on fan you take some points on fan at different distances, and if you rotate fan, then yes, you will see some circles. So that circles are, because that fan is performing rotational motion, so each and every particle will perform, yes, motion on circular path. Clear? So yes, if you have any object of any shape, if it is performing rotational motion, then each and every particle will perform motion on circular path. Clear about this? Okay. And yes, their centers will be fixed on axis of rotation. Clear about this? Now 1 or 2 points you have to remember for this. You see, the plane in which particle is performing circular motion is perpendicular to axis of rotation. Okay, a plane of rotation of particle is perpendicular is perpendicular to axis of rotation. To axis of rotation is perpendicular to axis of rotation. So yes, it is one easy point. The plane of rotation of particle is perpendicular to axis of rotation. Yes, friend, it is rotating in this plane, but its axis of rotation is vertical. Clear about this? So yes, plane of rotation of particle is perpendicular to axis of rotation. So yes, there are some definitions. What is rigid body? What is rotational motion? What is axis of rotation? Now, what about next definition? That is yes, you know two definitions. What is kinematics and dynamics? What is kinematics and dynamics? So again, kinematics, it is branch of physics in which you have to study only rotational motion without its cause. While in case of dynamics, you have to study motion with its cause and properties. So yes, it is difference between kinematics and dynamics that you already know. Now, in case of rotational motion, such rotational motion, yes, we have to start from basic. Remember chapter number 3. Motion in straight line, motion in 1D. Okay. First of all, we have to define frame of reference, then position, then distance, displacement, then velocity, speed, and then acceleration, and then force. Yes or no? So yes, we will take the similar flow here. That first of all, we will define some frame of reference, then position, then displacement, then velocity, and then acceleration. But what is different between linear motion and rotational motion? In linear motion, you have to use words linear. For example, linear velocity, linear acceleration. While in a case of rotational motion, you have to use word angular position, angular displacement, angular velocity, angular acceleration. Clear? So it is difference between them. Okay. So yes, now we will see some definitions related to rotational motion. For example, see here, if I am taking frame of reference, okay, for example, I am taking frame of reference like this. See, it is x-axis, y-axis, and here it is z-axis. Or yes, z-axis is perpendicular outside. Simple. Yes or no? Z-axis is perpendicular outside. Okay. And yes, I am assuming one object. For example, it is one object, one rigid body. It is one rigid body which is performing rotational motion about this OZ axis. About this OZ axis means like this. About this OZ axis means it is like this. Okay, suppose it is rigid body, it is performing rotational motion like this. It is performing rotational motion like this. Okay? Yes, it is performing rotational motion like this. See, you can see circles. So yes, each and every particle will perform circular motion. Clear? So yes, we have one rigid body which is performing rotational motion, in this direction. Okay? Chalo. Now, I am taking one point P. On rigid body. That it is at time t is equal to 0. Object is here and point P is here. Okay. So yes, here first of all I have to write, okay, let rigid body is rotating or performing rotational motion with respect to z-axis. Yes, you have to mention it. Okay, it is performing rotational motion with respect to z-axis. Okay, so I am taking at time t is equal to 0. Take a particle, take a particle at point P. At point P. Yes, I have one particle here. Okay, at point P. I have one particle here at point P. Okay, so first definition that we have to write is angular position. Okay, what is angular position? First definition, yes. What is angular position? What is angular position? So see, how to find angular position? First of all, connect this particle with axis. Connect this particle with axis. Simple. Connect this particle with axis. It will make some angle with reference axis, and yes, I will consider this x-axis as reference axis. As reference axis. As reference axis. So see, connect this particle with axis of rotation. Axis of rotation, it is like this. Axis of rotation, it is like this. So connect this particle with axis of rotation, means to center. Simple, to center. Okay, it will make some angle with reference axis, and let this angle is theta. Let this angle is theta. Okay, so this theta is called angular position. Theta is called angular position. Okay, so what is angular position? Angular position is angle between reference axis and line joining particle with its center. Okay, so how to write angular position means it is angle between line joining particle with center and some reference axis. Here reference axis is x-axis. Here reference axis is x-axis. So yes, at time t is equal to 0, angular position of particle is, angular position of particle is, at time t is equal to 0, particle is here, so its angular position is theta I is equal to theta. Why theta I? Initial position. And yes, angular position is indicated by theta. Angular position is indicated by theta. Clear about this? Clear about this? And yes, as angular position is theta, that is angle, its SI unit. Its SI unit is radian. Its SI unit is radian. So what is unit of angular position? Yes, its SI unit is radian. Clear about this? So yes, it is angular position. Now, as see, this object is performing rotational motion. It is, this point is at point P at time t is equal to 0. Now, as it is performing rotational motion, I will draw condition after some time. Suppose here it is, the same object, as it is performing rotational motion. Let after or at time t is equal to t, at time t is equal to t, this particle is at point p dash. This particle is at point p dash. Clear about this? So see here, initially this point p makes some angle theta with x-axis. Now see, as it is performing motion, this angle changes. Yes, this angle changes. So if I connect with this particle, this angle changes. So what is change in angle? Yes, it is called change in angle, and let it is delta theta. And let it is delta theta. So yes, I have to write second definition. What is second definition? Angular displacement. Angular displacement or angular displacement. Angular displacement means change in angular position. Change in angular position is called angular displacement is called angular displacement. Okay, see in this figure, at time t is equal to 0, angular position, that is theta I is equal to theta. Simple. With this x-axis, this p makes angle theta. Simple. Yes or no? Yes, it is. Now at time t is equal to t. At time t is equal to t. What is angular position of particle? Angular position theta f is equal to, yes, what is position? Now see, line joining particle with center, it is this line. So what is total angle with x-axis? It is theta plus delta theta. It is theta plus delta theta. So yes, it is theta plus delta theta. So see, there is change in angle. Yes, there is change in angle delta theta. There is change in angle delta theta. So therefore, change in angular position is equal to angular displacement is equal to angular displacement is equal to delta theta is equal to theta final minus theta initial is equal to, if you subtract this, you will get it is delta. Simple? Yes or no? Angular displacement is equal to this delta theta. And as theta, its unit is radian, its unit is also radian. What is its SI unit? Its SI unit is also radian. Its SI unit is also radian. Clear about this? So yes, what is angular position? What is angular displacement? It is simple. Now I will take one example and yes, I will explain. Okay? Yes, it is easy. See, for example, if it is x-axis, it is y-axis. Initially, object is here at point A, and then it is at point B. Simple. Initially, object is at point A. Initially, object is at point A, and then it is at point B. Then what is initial position? Yes, initial angular position theta I is equal to 0 degree. Simple, because it is on x-axis and it makes angle 0 with x-axis. Why? It is on P. So theta f is equal to, it is 90 degree, because this line makes angle 90 degree with x-axis. So yes, initial angular position 0, final angular position 90. So what is angular displacement? Yes, delta theta is also 90. Delta theta is also 90. Clear about this? So it is simple how to remember angular position and angular displacement. Clear? Yes, their units are radian and radian. So it's all about basic of this chapter. What is rigid body? What is rotational motion? Axis of rotation. Then angular position, angular displacement. I think, okay, you got it. Okay. So yes, it is about basics of this chapter. You have to remember this each and every definitions. You have to remember this each and every definitions. Clear about this? Okay. So yes, this is it for today.